Hello there, 8th graders. This is Mrs. Minowitz, and I'm here today to talk to you about how to balance equations. So remember, a chemical equation on the side that we're starting from is the reactants, right? It's the one where we're pointing to, and it always creates or yields the products. So our chemical reaction is set up where you have the reactants going to or creating or yielding the products. And one of the problems with the chemical reactions that are shown on the board here is that these are not balanced. And by what that means is I don't have the same number of atoms on one side as I do on the other. And this is a problem because according to the law of conservation of matter, we can't just have matter that just all of a sudden appears or disappears from somewhere. We can't have atoms appearing or disappearing on different sides of our equation. So we have to balance this and show how many of each different molecule or compound or element we have on each side. So we're going to look at how to balance these. Now this little subscript here tells you how many of the hydrogen atoms there are. So like H2 would be 2 hydrogen atoms, and the O2 tells you there's 2 oxygen atoms. When we look at the right side, we only have 2 hydrogen and 1 oxygen, and that's a problem because an oxygen disappeared, so we need to balance this equation. And we do this by adding coefficients, which are the numbers in front of them. And we'll take a look and walk through how to do that with several different examples from our worksheet in class. So the first one we're going to go through is N2 plus H2 creates NH3. This creates ammonia. That's NH3. So what we're going to do here is we're going to start off by writing how many we have of each substance. So we have we have 2 nitrogens because it's N2. So we have 2 N's, okay? And we have 2 H's, right? 2 nitrogens, 2 hydrogens. But when we get to the side on the right, okay, we have 1 nitrogen and 3 hydrogens. This doesn't balance. We need to fix this. And we do this by adding coefficients. So the first thing I notice is we have more nitrogens on the left than we do on the right. So I'm actually going to increase my number of nitrogens on the right by adding a 2 out front as our coefficient for our ammonia here. And when I do this, this applies to this whole molecule over here. So we need to update the amount we have. It's now saying we have 2 whole molecules of this, not just 2 of the nitrogens. So when we do that, okay, it's like distributing in math class. We take the 2 to the N and the 2 to the H3. So when we update this, we now have 2 nitrogens, okay, and 6 hydrogens. Okay, 2 times 3 is 6. That tells us we get 6 hydrogens because each of those molecules has 3 hydrogens. So altogether we have 6. Now if we look on the left, we've got 2 nitrogens. And on the right, we've got 2 nitrogens, so that's balanced. But our hydrogens now aren't matching. We have 2 on one side and 6 on the other. So what I'm going to do is I'm going to put a 3 in front of my H2 and say, hey, I would need 3 molecules of hydrogen gas. That's H2. And when I do that, okay, that'll update my hydrogens. So I now have a total of 6 because 3 times 2 is 6. So if I look on the left, I've got 2 nitrogens. On the right, I've got 2 nitrogens. On the left, 6 hydrogens, and on the right, 6 hydrogens. We are balanced. This works. So in order for this to react, I need 1 molecule of N2, 3 molecules of H2, and that would create 2 molecules of NH3. It's balanced. It's happy. That's the first one we're going to do. The second one we're going to look at is water and oxygen creating H2O2, which is hydrogen peroxide. And you're probably familiar with that substance. So we're going to look and see if we have how to balance this equation. So O's get a little tricky because they look like zeros. So we're going to have to make sure we're mindful of that as well. So if we look on the left of this equation, okay, we have 2 H's. Now, the O's are a little bit trickier because we need to put them together. We have 1 here, and we have 2 here, so we have 3 O's. Okay? I'm just going to write it here as 1 O first, though, and then 2 O's. Okay? And then on the right, okay, we have 2 H's, okay, and we have 2 O's. So our hydrogens are balanced, but our oxygens are not. So we need to fix that. So in order to fix that, okay, I'm actually going to increase my number of water molecules. I want to make this O an even number because it's an even number on the right side. So I'm going to take and I'm going to put a 2 right here. Now this 2 again applies to both the hydrogen and the oxygen. So if I do that, I'm going to update my numbers below. I have 4 hydrogens and 2 oxygens over here. Okay. I still have 2 oxygens here, so this together is 4 oxygens. So now I'm not balanced anywhere, but we're getting closer. Because, okay, if I look here, I have 2 hydrogens on one side, or 4 on one side, 2 on the other, 4 oxygens, 2 on the other. I notice that's double. So I just need to double, or put a 2 over here, and remember that it applies to both, and then take a look at our numbers here. So I've got 2 times 2 gets me 4 hydrogens, and then 2 times 2 gets me 4 oxygens. Okay. On the left, I've got 4 hydrogens and a total of 4 oxygens when I put it together. On the right, I've got 4 hydrogens and 4 oxygens as well. This is balanced. We're going to go through the next one here, okay, looking at sulfur and oxygen. We make sulfuric oxide, I think that is. So I have S8, okay, which is 8 sulfurs, and I have 2 oxygens. My molecule on the right, I have 1 sulfur and 3 oxygens. I need to increase the number of sulfur on the right side of this. So what I'm going to do is I'm going to take and I'm going to put an 8 out front here, okay, because there's 8 sulfurs on the left. And when I do that, I have to remember that this applies to both parts here. So when I update the numbers that I have, I now have 8 sulfurs, okay, and I have 3 times 8, which is 24 oxygens. So my sulfurs are now okay, we're balanced, but my oxygens are not. I have 2 on one side and 24 on the other. So what I'm going to do is I'm going to put a 12 here because I know that 12 times 2 is 24. So when I look at this one here, okay, I now have created a total, or have balanced to get a total of 24 oxygens there. So I have 8 sulfurs on this side, 8 sulfurs on that side. I have 24 oxygens on the left and 24 oxygens on the right. It is balanced. Okay. Next problem. We've got HGO, which is mercury and oxygen bonded together. So if I look at my left-hand side, I've got 1 Hg and 1 O. Okay. On the right, I've got 1 Hg, which is mercury, and 2 oxygens. So my mercuries are okay, but my oxygens are not. So I need to increase the number of oxygens on the left side in order to balance this. So I'm going to put a 2 right here so I can increase the number of oxygens. It also then increases mercury because remember it applies to both. So when I update my numbers, I have 2 mercury, okay, and 2 oxygen. Okay. On the right, now our oxygens are balanced, but now I need to fix my mercury so that they match. And I have mercury by itself, so this is an easy one to fix. So if I put a 2 in front of here, I now have 2 mercuries. Okay, 2 mercuries on the left, 2 mercuries on the right. 2 oxygens on the left and 2 oxygens on the right. I am balanced. Okay. Next one, flipping to the back side of the paper, we're going to look at one where we've got oxygen in a couple different places, so we're going to have to total up our oxygen here. So let's write out what we have first. I have 1 C and 4 H's in this molecule, methane. I have 2 oxygens, 2 O's here. Might be helpful. Sometimes students like to draw this line here like in math to look at what's balancing. Now on the right, okay, I have 1 carbon. Okay. I have 2 oxygens. I have 2 hydrogens, and I have 1 oxygen. Okay, this one's a little bit trickier because you end up with oxygen and 2 molecules on the right side. And what I recommend that you do is if you have O2 on the left side, you know anything you create is always going to be an even number of oxygens. So on the right, we have water here, which only has 1 on it. So my first step is actually going to be to put a 2 in front of this here, because I know that I'm for sure going to end up with an even number of oxygens, which is kind of the tricky part with oxygen. But remember, again, this applies to both the hydrogen and the oxygen in that molecule. So I'm going to update the numbers that I have here. I now have 4 hydrogen, okay, and I have 2 oxygen. Okay. So my carbons are good. I've got 1 on each side. My hydrogens are good. I've got 4 on each side. But my oxygens are not. And that's because on the right side here, I have to remember that I have oxygen in 2 places. I need to combine them. I have a total of 4 oxygen, and I only have 2 on the left. So what I'm going to do is I'm going to take and I'm going to put a 2 out front here to double the amount of oxygen on this side, and I'm going to end up with 4 oxygen on the left side. All right, we're going to stop here walking through this. I will also walk through some more in class with you and go through some more practice with this and give you some more options for looking at how to balance equations. Thank you.